the quadratic using the quadratic formula. So I need you all to listen for a second. I don't know if you guys got this last year, but when you're solving a quadratic, you guys, this is what you're finding really quick. So when you're solving a quadratic, you're finding the x-intercepts. So you're finding these values where it crosses the x-axis. Did you know that? Okay, awesome. So once again, when you're solving a quadratic, you're finding where it crosses the x-axis. Now, if you have a quadratic that never crosses the x-axis, that doesn't mean there are no solutions. There are. There's still, quadratics have 2 solutions every time. Highest degree is the number of solutions, right? But these are when you'll have imaginary solutions. So you know how we get sometimes in the negative under the square root and we pull out 9? That's because you have a parabola that looks like this, never crosses the x-axis. Does that make sense of where your imaginary solutions are coming from? Okay, so with that being said, understand when solving a quadratic, there's many different methods to solving. The quadratic formula always works. Here's the deal with the quadratic formula though. 9 out of 10 students cannot do it correctly. So if you guys will listen to me and what I'm, like little tidbits, you'll be able to do it right. So first of all, it has to be set equal to 0 and in standard form. So we have 3n squared plus 10n is equal to 5, so I'm going to make it equal to 0. So I have 3n squared plus 10n minus 5 is equal to 0. Does everybody understand how it's in standard form, which means highest degree to lowest degree? So then my a value is always in front of x squared, so my a value is positive 3. The signs matter here. My b value is positive 10. My c value is negative 5. Then you have to know the quadratic formula, which it blows my mind how many people don't have it memorized. So we did learn a song. My secondary 2 kids sing the song, x equals negative b. Do you guys remember that? Okay, let's all sing it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have x equals negative b, which means the opposite of b. So guys, that doesn't mean negative b. Everyone's like, well, b is always negative. No, it means the opposite of b plus or minus the square root. Now watch, you have to use parentheses. B squared minus 4 times a times c. Do you see how I'm putting in parentheses? Yes. And it's all over 2a. Now look, I saw a lot of you putting only this over 2a. You went like this, that over 2a. Wrong, guys, wrong. It's all over 2a. Does everybody understand that? Okay, so let's plug it in carefully using parentheses. I'm telling you, parentheses are a must. So we have x equals the opposite of b, so it'll be negative 10 plus and minus the square root of b squared. Always using parentheses. 10 squared minus 4 times a times c, which is negative 5, and it's all over 2 times 3. Okay. So now, you have to listen to what I'm about to say, because this is where most students cannot get it right. You need to plug only this piece into your calculator. Do not type in the square root part, or else you're going to end up where you can't continue. Because what if you got a decimal, or what if it was a negative under there? It'll say error. Or if you get a decimal, that's not acceptable as an answer at this level. So I'm telling you, only type in this part so that we can continue to simplify by hand. So type it in. You guys, now listen. Type it in exactly as shown with the parentheses. And then tell me what you get. What is it?
160.
So we have negative 10 plus or minus the square root of 160 all over 6. Now, here's where a common error comes in. Students say 10 and 6, they simplify. You cannot do that. Unless all 3 things simplify, you cannot just divide those out. Do you all understand what I'm saying? So now this is the step. Now if you go in your calculator, type in the square root of 160, did it come out to be a whole number? No? So this is where you have to go off to the side and say, what is the square root of 160? So factors of 160, 16 times 10, right? 16 breaks down into 4 times 4. 10 breaks down into 5 times 2. And then we could go as far down as 2 times 2. Then we're pulling out groups of 2 since it's a square root, right? So if there's 2 of them that can come out. Now understand, what we are technically doing is taking the square root of 4, which is 2. So we only pull out 1 2 for those 2 2's. Do you all understand that? So then we pull out another 2 2's. And then we have have this that can't leave, this that can't leave, right? So we pulled out 2 times 2, which is 4. And then left underneath was a 5 and a 2. Anything you pull out, you multiply. Anything left underneath, you multiply. Because technically we had a 10 left underneath. Does everybody understand that? So we have 4 square roots of 10. So this piece simplified to be 4 square roots of 10. So I'm going to rewrite it. So I have x is equal to negative 10 plus and minus 4 square roots of 10 all over 6. Does everybody see how I simplified it? You understand like the little rules of not like typing it in your calculator and whatnot. Okay, so then from there, do all 3 things simplify? Does 10, 4, and 6 simplify? Yeah, they all divide by 2. But you can never divide something that's underneath the radical with something that's not, right? So this 10 isn't going to simplify. You all understand that? Yeah. So this divided by 2 and is a 3, this is a 2, and a 5, right? So negative 5. So our final answer will be x is equal to negative 5 plus and minus 2 square roots of 10 all over 3. And there's 2 answers. If you needed to split it up, you'd have negative 5 plus 2 square roots of 10 over 3 and negative 5 minus 2 square roots of 10 over 3. Does everybody see how to use the quadratic formula appropriately and correctly? Okay, so good. So I'll get 100 on your belt list. Pass it in. As you do, I just want you to look right here for a second. So let's say we would have done the quadratic formula and got something like this as when we did the quadratic formula. Because this is still, like a lot of you, I even saw on like our our final exam that people weren't able to do this. So look, we have 2 plus or minus the square root of 5 over 3. This is always where we say, well, what is the square root of 25? It's equal to 5. So really we have 2 plus and minus 5 over 3. And then guess what? People stop there and put that as their answer. That's not correct. So what you would do is split it up and say, okay, so we really have 2 plus 5 over 3, and we really have 2 minus 5 over 3. Now, still not an acceptable answer. Now, here's the other thing. People just take their calculator, type it in, they get it wrong. Because you actually got to add up, what is 2 plus 5 on top? 7, right? So we have a 7 on top and a 3 on bottom. I promise if you type in your calculator 2 plus 5 divided by 3, you will not get that same thing. Do you understand what I'm saying? You have to actually add the top together before you divide. Okay, so then what's 2 minus 5 over 3? Negative 3 over 3. Huge difference. Which is what? Negative 1. So our 2 answers are negative 1 and 7/3. We would leave it as a fraction, not a decimal. Do you understand how to do something like that? So what if it came out to be this? Let's say we had negative 3 plus or minus the square root of negative 49 over 21. This is where you go off to the side and say, what is the square root of negative 49? Don't say it's negative 7. Not true. What is it? We know that the square root of negative 49 is the same thing as 49 times negative 1, right? What's the square root of 49? What's the square root of negative 1? I. Good. So really this became 7i. So we have x is equal to negative 3 plus or minus 7i over 21. Now do all 3 things divide by something? The 7 divide by 3? No, I actually did the same thing when I was looking at it. I'm like, oh, 3 and 7 multiplied by 21. So we just have to be really careful to make sure. So they don't all divide by anything, right? Okay. Do you guys see how to simplify these? I'm just concerned a little bit. Okay, awesome. Okay, let's get to, so yesterday we learned the sine function. Super hard, I know it is, okay? So we're going to spend another day finishing up the back page. Does that sound fair? Yeah. Okay, awesome. So just a couple review, then we'll just get started. So remember, where the sine function comes from is technically from the unit circle. So remember, when we're talking sine, we're talking y values. So we're really just modeling the y values around the unit circle, but we're drawing it as a function, and we only are looking at sine. So since sine are y values, remember, we start at 0, 0, right? Does everybody see how my function sine starting at 0, 0? And then it starts to increase up to 1. So it increases up to 1, right? And then after it hit 1, it started to decrease. The function decreased to 0. So after it hit 1, it decreased to 0. Then after it decreased to 0, it continues to decrease to negative 1. So after it hit 0, it decreased to negative 1 on the y-axis. And then after it hit -1, it increased up to 0. So after we hit -1, we increased up to 0. And then I just filled in the stopping points. So at 1, on the y-axis, we were at pi halves. And then we decreased to pi. And then we decreased again to 3 pi halves. And then we increased up to 2 pi, right? Because this was 2 pi. Does everybody see, once again, where the sine function comes from? So we could go around the unit circle again, and it would do another wave, right? Go around the unit circle again, another wave. Does everybody see how this works? Okay, awesome. So remember, we learned that the equation of the sine function is y is equal to a times sine of b theta, where a is the amplitude, and you have to look at the absolute value of a, because the negative in front just means it flips it over the x-axis. The negative in front just flips it over the x-axis. So a is our amplitude, how far up from the midline, how far down from the midline. And then b, this is where a lot of you were accidentally saying that that's the period. But remember, b is just the number of cycles. And here's the kicker part, the important part. It's the number of cycles between 0 to 2 pi. Okay, so that b value is the number of cycles from 0 to 2 pi. And then we can algebraically find our period, which is the physical length of one cycle, by taking 2 pi divided by that b value. And it took some algebra. So that's the physical length of one cycle. Okay, so let's just practice graphing one from yesterday, from the front. So check your answer. I know you did this one. I was checking your answers. So it says, sketch one cycle of the graph of each sine function. So we're sketching one cycle. So that's very important. You've got to read the directions. It says one cycle. So first of all, I'm going to write out what my amplitude is. So we know that the amplitude is the absolute value of a, which is the absolute value of -2, which is 2. So we're going up 1, 2, down 1, 2. And I like to draw in just some asymptotes so I know I've got to touch that but not go over that. So that's how high up and down. And then it says we're sketching one cycle. So I'm going to draw in a cycle next. Does everybody understand? Because a lot of you were trying to do your ticks next and it makes it really hard to draw in an appropriate graph. Let's put the tick marks in last. Does that make sense, everybody? So I draw in one cycle. Now we got to be careful. Because of the negative, we've got to go down first, right? So we're going to go down, touch, back up. And when we hit the back down, we're now starting we're ending where we started. So we've drawn in one cycle. So now we're going to label it, but to be able to label it, we have to know a couple things. We need to know the length, the physical length of that one cycle, right? So we're going to have to do, that's called a period. Period is equal to 2 pi divided by b. So we have 2 pi divided by 4, which is 1 over 2, which is pi half. So the physical length from here to here is pi at pi half. Now I wanted you to label in at least a couple more points. So then divide pi half by 2, and you get pi fourths. Divide pi fourths into 2, and you get pi eighths. So now from here, this is where a lot of people are like, I don't know what should be right here. So count it like this. We know this is 1 pi eighths in distance, right? This is 2 pi eighths, because look, 2 pi eighths would simplify to be pi fourths. So this is 3 pi eighths. And then this is 4 pi eighths. Check it. 4 pi eighths would simplify to be 1 over 2, so that is pi halves. Do you see how I filled it in? And we're done. It wasn't too bad, hopefully, today. Did it seem a little easier today? Yeah. Okay, good. Let's do another, one more, but it's asking a little bit different. So, asking something a little different. It says, determine the number of cycles each sine function has. Oh, so this one wasn't actually one. But we're just going to get started on the back page now. Okay, so it says, determine the number of cycles each sine function has on the interval from 0 to 2 pi, and find the amplitude and the period. So first of all, amplitude is what? The absolute value of -2, which is 2. Does everybody understand how in this example my amplitude is 2? Then b is the number of cycles from 0 to 2 pi. So, what is it? Number of cycles between 0 to 2 pi. 1/3, right? Can't we just rewrite this as 1/3 times theta? Isn't that b theta? B is the number of cycles from 0 to 2 pi. So b is 1/3. That's the number of cycles from 0 to 2 pi. So there's only 1/3 of a cycle drawn from 0 to 2 pi. And then our period, we know, is equal to 2 pi over b. So 2 pi divided by 1/3. You've got to type, or I like to just do it using algebra, but let's say you didn't want to. Take your calculator, do 2 divided by, you have to use parentheses. 1 divided by 3 in parentheses. What do you get? Now you can't type the pi in, your calculator won't work that way. So it can't change it to a fraction. So you got 6, right? So we have 6 pi. So the length of one full cycle, to get a full cycle, we have to go clear to 6 pi. Does everybody understand? And we're done. We've answered the questions. It didn't ask us to graph on this one, although we could. Okay, so do problems. 14 through 18, check with me when you're done, so that you can do the rest right. So you need to you really got to read the directions, because this one's different than any of the graphing ones we've done before. So it says, find the period and amplitude of each sine function. Then sketch the function from 0 to 2 pi. So did it say that we're only sketching one cycle? No, we're going to sketch however much we need to get to 2 pi. So the first thing I do with something like this is say, well, pretty much the same steps. What's my amplitude? 4. Okay, good. So I'm going to draw in my amplitude. So up 1, 2, 3, 4. Down 1, 2, 3, 4. And then I'm going to draw in my dotted line here, which this is going to end up being a pretty long one. Okay. So then from there, we need to know, since we're going from 0 to 2 pi, how many cycles are we going to be drawing, right? So we're not just trying one cycle. Do you guys see that if you do this wrong on the test, you're going to get it wrong? So it says, draw up to 2 pi. So with this one, we know that this b value is the number of cycles from 0 to 2 pi, right? So the number of cycles we're going to draw is 5. So we have to draw in 5 full cycles, and then we'll be reaching 2 pi. So I'm going to draw in 5 cycles. Now be really careful, because when you start drawing cycles, you tend to forget where you started and get off. So just be really careful. I like to do like a little kind of like dots to make sure I know where I stopped. So it's not negative, so I'm going to go up first. So I'm going to draw in 5 cycles. So 1, and I draw a dot so I know that that's the end of a cycle. Does that make sense, everybody? Now I'll draw in another one. We're drawing in 2. I'm not drawing them in perfect, that's okay. I put a dot so I know that that's the end of another cycle. 3. 4. And 5. So we're drawing in 5 cycles from 0 to 2 pi. So now, that was from 0 to 2 pi, so I'm ending at 2 pi, right, everybody? So this one's really squished in, ding, 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 right? Between 0 and 2 pi, right, everybody? You understand there's a lot of waves? Okay, awesome. So now, we want to know what's the length of one cycle. That's called a period, guys. We know period is 2 pi divided by b, right? So 2 pi divided by 5, guys. Okay, so the length of one cycle was 2 pi fifths, right? So from here to here was going 2 pi fifths amount, right? So I'm going to write 2 pi fifths. So now you'll have to say in your head, we're going another cycle, so we're adding another 2 pi fifths, right? So 2 pi fifths plus 2 pi fifths is 4 pi fifths, right? Yeah. Okay, so from here to here, we've gone 4 pi fifths. So let's add another cycle. So we're going to do 2 pi fifths plus 2 pi fifths plus 2 pi fifths, which is 6 pi fifths. So this will be 7 pi fifths, right? Let's make sure we ended right. 8 pi fifths. What did I miss?
Wouldn't that one be that is you?
No, the 7 would be 8.
Yeah, there we go. I knew I did something weird. Okay, so let me fix this. This was 2 pi fifths plus 2 pi fifths plus 2 pi fifths, which would have been 8 pi fifths. Sorry, I only added 1 for some reason. So then this is 5/5, right? Which, let's see if that's where we ended. What's 2 divided by 5? 10 divided by 5. 2. So you see how we ended in the right spot? Okay, sweet. So really that's as detailed as I need you to get. Now you could split 2 5/5 in half, right? I mean, I'm not going to make you go that far. But I'm just giving you, like, saying we could if we wanted. Okay, that's good enough. It wasn't too bad, was it? Make sure you only sketch from 0 to 2 pi. Do not go past 2 pi because it says sketch on an interval from 0 to 2 pi. All right, so do problems. Finish the worksheet. Sorry.